Hello everyone, I'm Stefan Bocutiu from Landup, and in this webcast I will show you how Lenses allows you to build an end-to-end IoT data pipeline over Apache Kafka with just a few lines of SQL code. For those of you who don't know, Lenses is our data streaming platform built on top of Apache Kafka. Our goal is to make the famous open source product even easier to use and accessible to wider audience who might not have the coding skills or the in-depth knowledge to use it as it is now. The rapidly growing number of interconnected devices confirms the Internet of Things, or IoT, is a fast and maturing technology. We live in an era where digital economy is moving forward at a fast pace. Like the typical economy, the digital one has its own currency, and that currency is data. IoT is an important driver for being data rich. However, having the data is not quite enough. The data is only valuable if you can actually make use of it. A typical IoT data pipeline involves a myriad of sensors streaming various information. The stream of data is then continuously analyzed to produce various metrics or work out trends. The end result is then pushed into a storage system. Let's have a look now of how we can build an ETL pipeline by leveraging Lenses and Apache Kafka. Obviously, the pipeline is targeting the IoT world. For those of you who don't know, MQTT stands for Message Queue and Telemetry Transport, and it is a publish-subscribe, very simple and lightweight messaging protocol. It has been designed for low bandwidth, high latency, and unreliable networks. This makes it ideal for the Internet of Things world, where bandwidth and battery come at a premium. We have a network of sensors pushing metrics into an MQTT cluster. Using Kafka Connect framework, we are going to bring the data into Kafka. Once the data is available in Kafka, we're going to run a Kafka Streams application to compute a min, max, and average temperature over a window of time. The end result is stored back into Kafka, and that gives us the option to use Connect again to push out the results into an instance of InfluxDB. Lenses is the key element here, making the entire task a lot easier. How? It gives you the connect management capabilities to provision and monitor your connectors. It gives you the Lenses SQL engine, so you can write your Kafka Streams application SQL-like syntax, obviously with monitoring and scaling out of the box. Furthermore, you get the endpoints and the Redux.js library to integrate with Lenses if you need to. I'm going to wear my developer hat today, and I'm going to build the pipeline I've mentioned locally. Typically, to develop something like that locally, I would need a Kafka environment. That means I would need a Kafka broker, a Zookeeper node, I would need my schema registry running, I would need my Kafka Connect worker running, I would need to download the connectors, in this case the MQTT and InfluxDB. I would need to write, compile, and deploy my K-Stream application. I will need to build a dashboard. Or I could just use Lenses Developer Edition, which is free, and achieve all the above in a couple of minutes, rather than hours and days, depending on how accustomed you are with the environment and with Kafka, and obviously writing JVM code. To find out about Lenses, you could navigate to lenses.stream. That's the page that gives the entire documentation, and you get an idea of the functionality support. As I've already said, Lenses development environment comes free, and it packs everything you need to develop locally. It has all the connectors we support and develop at Landup. Furthermore, the Docker image, the Lenses development environment comes in the form of a Docker image. The Docker image contains data generators to get you going faster. Of course, you get the Lenses UI, the Lenses SQL engine, and access to all the REST endpoints in case you need to integrate with Lenses. So before going forward, I'd like to take a moment and talk a little bit about SQL engine, SQL engine for Apache Kafka. As you can see on the screen, at the bottom of the stack, there is Kafka with the two APIs, one for client and the other one for Kafka Streams. This allows the SQL engine to unify the access to Kafka. That means you can run batch queries and streaming queries utilizing the same syntax. It is that simple. Lenses as a platform takes care of running, monitoring, and scaling the SQL processes. In the developer edition, you get one of the 3 execution modes, and that is the in-proc option. That means any SQL processor, an SQL processor is our terminology for Kafka Streams application, lives in the same space as the Lenses process. For the enterprise customers, we do offer 2 extra modes to actually meet their demands. The first one is leveraging Kafka Connect to run and scale the SQL processes, whereas the second one is using the very buzzy Kubernetes container orchestration to provision a pod for each runner. How do you get Lenses? To get your hands on the developer edition, you'll have to navigate to landub.com, follow the downloads button, go for the developer edition, provide an email, agree with the license, and click the Get Lenses button. Shortly after, you should receive an email from us describing or giving the command to run Lenses locally. That command should look similar to what you see now on the screen. Just one thing before I launched it, I am actually disabling the MQTT source that we pack in the Docker image, and I'm actually using a newer version of that code. That newer version can be picked up from GitHub by just going to our Landub area. I'll go back there to show you. So you'll find all the connectors open source. So going back on the MQTT, to use a newer version of the code, you could either use the jar that I'm selecting here, or pick it up from the release. Either one is good. The reason for using this newer version for the connector is because we allow now for the MQTT incoming message to be streamed into Kafka by retaining, let's say, the sensor ID in the Kafka message. I'm going to run Lenses now. By the way, everything that you see here in the video is going to be accompanied by a blog, so don't worry. You'll have all the steps required to do everything or to run everything locally. Normally, it takes around 30 to 45 seconds for the Lenses Docker image to start properly. And I say properly to bring all the processes up and have everything running. So while it's doing this, we can move to the next step. And the next step is to provision our InfluxDB database. InfluxDB is an open source time series database handling high write and query loads. It has been written in Go, and it can handle quite a large amount of data such as application metrics, IoT sensors, data, and real-time analytics. At Landub, we provide the most advanced Kafka Connect sync for it. Again, you can follow the lenses.stream URL, and you can get to the documentation by going to the connectors menu. To get our instance of InfluxDB running, we're gonna go back to a Docker image for the 1.3 version, and we're gonna spin it up in a matter of seconds. Actually, I've already done that. So the first thing I need to do is to set up a database for it, and I'm gonna name this database IoT. Now let's see if we actually created a database. So now we're gonna run show databases. As you can see, the database is there. So we can move forward to the next step, and that is to actually generate some data to play with. Of course, we're not gonna have access to a real network of sensors. To mimic the data, I've provided a small application. You can find it here on the GitHub. You can go back to the web page, to the MQTT sensor data. You can grab the release, either the zip or the tar, depending on your system, download it, unpack it, and make it available to run, as we will do now. The application is coded in Kotlin, for those of you who are curious, and it embeds a MQTT compliant broker by utilizing the open source Mocket project. Now let's get going and get the MQTT cluster running and have the data being generated. The application takes two arguments. The first one is the port for the MQTT broker to bind to, and the second one is the topic to send the data to. We're going to run this, and you can see we have data coming through. For the sake of the exercise, I'm only using 4 sensors, so you'll see only 4 IDs in here, SP01 to SP04. Now that we have data, we should move forward and bring it into Kafka. To do so, we're going to leverage Kafka Connect framework. Kafka Connect framework comes with Apache Kafka and is targeting, or is the product or the framework to use if you want to move data in and out of Kafka reliably and at scale. As you can see on the screen here, we have the configuration for the MQTT sensor source. There are 2 key elements to it. The first one is the KSQL entry. The KSQL is our take to configure connectors for Kafka, and that is to simplify. In order to simplify the settings, we came up with this SQL-like syntax that quickly describes. You don't have to know much about the connected code to actually work out what the insert statement is telling it to do. So to go in a little bit more detail, the Kafka Connect framework will pick up data from the MQTT topic /sensor_data and will push the entire payload, select star, into sensor data topic. While it's doing so, is using the ID field. The field is part of the incoming MQTT payload to actually populate the Kafka message key. In order to translate the incoming JSON to a Kafka Connect struct object, it uses the JSON simple converter. The second part of the configuration is the connection, and since we're running everything locally, we're connecting to the local host and the port we just told the MQTT application to bind to. Now let's go ahead and actually log into Lenses and provision our connector. To log into Lenses, just navigate to localhost 3030. Use the admin credentials to log in. You can see this is the screen that gets you into Lenses. This is the dashboard. Now to just go to the connectors. I'm going to provision the MQTT source. Get a list of all the connectors we distribute in the developer edition. I'm going to type MQTT to filter them. On the left hand side, you have the source which we need. I'm just going to grab the configuration as you've seen on the screen earlier. I'm going to provision the connector. I have everything ready. I'm going to create the connector. It takes a few seconds for the task to be spinned up. And now in the list of connectors for the dev cluster, we see the MQTT source connector. Let's go to topics. And now you can see we have the sensor_data topic. If we click on it, we're going to get to see actual data coming through. To take it a little bit further, if you want to see the data coming from a specific sensor, you can just use SQL and filter on the key. Let's say in this case where I want to see only the data coming from the sensor with the ID SP01. Let's go ahead and run this. When we execute this, we see now only the data from that sensor. This is the screen that handles live data. You can go to the data screen and you can see the already stored data, and you can go there and browse for existing data. It's very simple. Anyone that's written any SQL statement can do so. Let's say now that I want all the records for our sensor with ID 01 and temperature let's say smaller than 25, sorry, 25. On this, there's a problem. I missed my end. I fetch data, it has a limit of 1,000, so you can see now I've only got records where the temperature is less than 25 degrees Celsius. Now that we have the data ready, we can move forward to actually write our LSQL processor. On the right hand side, we have the entire LSQL code for our processor. The processor is supposed to calculate min, max, and average temperature and humidity for each sensor over a window of 2 seconds. I'm not going to go into all the details about LSQL. You can find more on the documentation page. The insert basically says grab all the results and push them into sensor underscore data underscore average. The first select statement is declaring the equivalent of a temporary table for a normal SQL database. You can see we declare it with a with syntax, so we declare average stream. This average stream takes all the incoming records and obviously does a count to count how many we had over that 2-window interval. It sums the temperature, the humidity, it grabs the min and max for both humidity and temperature. It grabs the key as the sensor ID, and then it groups by that key. The second part of the query, or the second select, is leveraging average stream to actually calculate the average. And to do so, it does the temperature total divided by the total, which are columns exposed by the first select statement. And obviously the results, as I've said already, are pushed into the target topic. We're working actively to provide an average function to do all the above and obviously have an easier version of the code doing the same thing. Now let's go ahead and provision our LSQL into Lenses. For that, go back to our Lenses application, our Lenses UI, go to the SQL processor, hit the new processor button, let's name it IoT. In this case, we don't want to scale it, we'll leave it to just one runner. And let's create the processor. Right, so the processor has been created, and now you already see data flowing through. The nice thing we do on the Kafka Streams / LSQL processor, we provide the topology the data is following, the stream topology for your data. You can interact with the nodes in the graph. You can see by default the results are the records that are pushed into the sensor data average. And if I want to see the incoming data, I can just click on the topic sensor data node and I can see my incoming data. As I said, you can interact with any of the nodes and that will give you a bit more details of what the node does. Now we have the MQTT data. In Kafka, we process that data, we push it back into Kafka, and now it's time to move that data out of Kafka and into our persistence storage. We've chosen, in this case, InfluxDB. It's quite a typical solution for IoT. Again, we configure the connector via KSQL, and in this case, we say to the sink, pick up all the messages from sensor underscore data underscore average and push them into the sensor measure into InfluxDB. And while each InfluxDB point is being built, let's tag that point with the ID. The ID is the actual ID of the sensor, and then we have a constant tag for the point, which is Lenses. As you can see here now on the mouse, we are actually using the IoT database we created earlier. So let's go ahead and see. Actually, I haven't actually provisioned the connector. Let's do so first. Otherwise, we're not going to get any data into InfluxDB. For that, we're going back into the connectors screen. This time, we're going to pick up InfluxDB. Paste the code. Ready now. Click the create connector. A few seconds later, you should get the the task provisioned, and we're good now to actually check whether we have data in InfluxDB or not. To do so, I've already created the query. So we're selecting everything from sensor measure and displayed on the console. There you go. We have data in InfluxDB. One of the things we're very thrilled to deliver in this 1.1 release of Lenses is the first ever native Kafka topology view. That means you can create your ETLs over Kafka and have one screen that gives you the high-level view of your entire data pipeline. We cannot stress how important that is, and let's see it in action. Go back to Lenses UI. At the top of the screen, you get a topology link. If you click on that, you're going to see the current topology. Of course, because I've only created one, you get to see only this. The more you create, the more complex this graph becomes. Similar to the SQL processor UI, you can interact with any node in here. So you can interact with the source and get an idea of what the source is, the task, all the details related to it. You can see the topic. In this case, we do not subscribe for live data, but we provide information about the topic. And if you want to go to the topic, you can just do so by just clicking on the sensor data here. By clicking on the processor, you can actually see the SQL processor topology with all the nodes. You can interact with them, but in this case, again, we do not subscribe for live data. And then, as we did with the source, we can do the same thing with the sink and get the details of our InfluxDB instance. Amazing, isn't it? What if I want to integrate my web application with Kafka? To do so, we expose a couple of REST endpoints in Lenses, and furthermore, we provide a Redux.js library for the developer to pick up from npm and use it if it's required. In this case, we've done an example. There's an example for the topology we built, and you can find the code on GitHub again. It's all open source. Let's go again to the web. On the GitHub Github area, you'll find Redux Lenses streaming example. Please make sure you take the feature chart. It has obviously the chart part of it. You're gonna see shortly. So let's go and run this. Obviously, you have to do npm install and then npm run start dev. You find all the details about compiling and executing the application on the GitHub account. I'm gonna run the application. Takes a few seconds to spin up. It's ready. Go back to the browser, type in localhost 8000 Lenses, and it takes us to the UI. The first thing we need is our Lenses endpoint. Obviously, we need a client ID, and because Lenses is using authentication, we need to type in our admin credentials and hit the connect button. Now we hit the connect button and we are subscribed. We can get to our data fairly quickly. I've already prepared the SQL. The SQL is basically pulling data from sensor data average, and to do so, it needs to specify the key type and the value type for each message. Let's hit subscribe and see what happens. Just 1 second later, you can get all your data. Let's use the data for your first sensor, the one with the ID SP01. You can get the average temperature graph. Obviously, we can change that to the third one, and so on. Thank you very much for taking the time to see the entire video. Like I said, the slides and the blog will be made available as well. We'd love to hear from you. If you want to contact us, you can just navigate to landub.com, write us an email at info@landub.com, write us at our Twitter account, you name it. Thank you very much. Have a good day.